Okay, good afternoon, everybody. So this is work that we've done in our lab at BYU to bring usability to secure email for the masses. Usable secure email is a decade-old problem. We've had a lot of problems with that in the last few years, and our focus is on improving usability, specifically for novice users who might not be computer security experts. And so to that end, we developed the POEM 1.0 system, which was an integrated secure messaging system, and we had some great success with that. We got really strong task completion rates, but there were a few lingering problems we wanted to address. And so in this 2.0 system, we applied 4 main user interface revisions to increase usability, and the end result was the most usable system for secure email that we have seen so far. I want to describe the security of email, or lack thereof. You can think of email like a postcard. When you write a message on a postcard, you can read it, your friends can read it, but anyone who handles that postcard can read your message in its entirety. And email is the same way. So you write an email, you can read it, but all your email providers can read it as well. Now, some providers will communicate with each other in the clear, and this simply invites surveillance. And even if they do communicate securely, those links are open to attack through man-in-the-middle attacks. So secure email is the idea of encrypting your messages before they ever leave your computer. So it doesn't matter if your email provider can read the messages or not. All they see is encrypted ciphertext. And another term for this is end-to-end encryption. Now, as far as the current state of secure email, there's a few different ways we can go about this. Secure email depots are third-party services that manage the user's secure communications, and they'll typically provide a client to the user to manage the encryption and decryption of messages. However, these are inconvenient, and it's very hard to guarantee that the end-to-end encryption is actually happening. PGP is a very well-known form of secure email, but it is very confusing to use. It utilizes a form of communication called the web of trust, where I will trust someone who trusts someone else, who trusts someone else, etc., and it quickly becomes very unmanageable. SMIME is very similar to PGP, and it's used in governments and businesses, and it works really well when it's supported by an IT staff to handle things such as certificate issuing, revocation, signing, etc., things that normal users just don't want to deal with. And so the problem that we see here is that nothing is really targeting average users of the internet. So as far as the usability of secure email goes, it's been a problem for a very long time. Back in 1999, the Why Johnny Can't Encrypt paper was published, which really opened up the field of usable research in secure email. It was a study of PGP 5.0, which at the time was the most touted platform for providing secure email functionality. And they found that half their users couldn't even set it up properly, and only a third of them were able to successfully send encrypted messages using the system. More recently, we evaluated the Mailvelope tool, which is a modern PGP client, and we got even worse results. Only 1 in 10 users were able to successfully use it. So in our lab, what we want to do is really make secure email usable for the average user. The first stage of this effort is to really prioritize usability, possibly at the expense of security. We know how to make secure systems, but usability has been a problem, so we want to really nail usability. Then, once we've done that, we can ratchet up security and use the lessons we learned to maintain usability at an acceptable level. The end result will hopefully be a really secure, really usable system for novice users. So to that end, we developed and designed the private webmail system, or PWM. We pronounce it as POEM. It's sort of a play on words from the colloquial pwn from gaming and hacking. So it is integrated into webmail, which by that we mean that we inject secure elements into a web page that the host web page can't probe and get the contents of. We did this because we found in our research that users really dislike depots and other thick clients. So we wanted to do an integrated route. And we hid as many security details as we could and automated all the key management so we could stay out of the way of users and make it really, really usable. And the result was really strong usability scores and excellent completion rates. Nearly all of our users were able to successfully use the system. In 2.0, we wanted to address a few shortcomings, particularly the mistake rate and the user trust. These are both problems we saw in the 1.0 system. As far as mistake rate goes, we found that a number of users were accidentally sending sensitive information in the clear without having first enabled encryption. And for user trust, we found that users weren't actually confident that the system was doing anything to protect their messages. It was, in fact, too integrated to their regular workflow. So the strategy we used to develop the 2.0 system was to perform iterative improvements. We would have a collection of ideas, we'd flush them out, run cognitive walkthroughs in our lab, and then implement the ideas and run small-scale studies with friends and family. The end result was 4 main improvements that we applied to the 1.0 system for this next generation version. And I'm going to show you some screenshots to illustrate what those improvements were. I'll note that you'll see the term message guard up here. That's simply the most recent name for this system. So it starts with a really professional-looking website. We found that users of our first system were a bit put off by the sort of haphazard and thrown-together nature of the install page. So we designed a really clean, modern look, gave a very prominent call to action to have them install the tool. Once they'd installed it, you see we have this modal dialog here, and this gets into the topic of tutorials. In the 1.0 system, we provided video tutorials for the user to teach them how to install and use the system, and those were on the installation webpage. We found that hardly any users were actually viewing these tutorials. They'd simply go ahead and try to use the system on their own. And so we wanted to improve that by implementing context-sensitive inline tutorials that show the user what they need to know when they need to know it. So you see here we're instructing the user on how to actually enable encryption and get to work. And this actually illustrates another improvement we made, because in the 1.0 system, all the controls for toggling the encryption activation mode were at the bottom of the compose window. So users would follow the normal flow. They'd fill in the to field, the subject line, the body, and only then would they realize that encryption wasn't actually being done. So we revised that by moving the encryption toggle to the very top where they'd see it at first. So they've enabled encryption, going out to subject. This is a greeting field we added to allow users to provide context to the receivers. If someone doesn't actually have the software necessary to decrypt their messages that they receive, at least they can read this plain text bit and see, oh, this is who it's from and here's what it's about, here's why I should bother decrypting it. And now we have the main compose interface. We moved to a very distinctive white on blue background because in the 1.0 system it was exactly the same color scheme as Gmail, and this went back to the root of lack of trust and mistakes. So we provided this color scheme so users could be very confident, oh, here's where I can type in my sensitive information and it'll be protected. Now, when the user has hit send, they get this animated spinner icon that says they're encrypting the message. In modern computer systems, we can encrypt data very, very fast. And so in the 1.0 system, we allowed it to encrypt data as fast as the computer was able. And users didn't see anything happening with their messages. They'd hit send and it was gone. And they couldn't tell that anything was being done to protect their messages. So to revise that, we added an artificial delay of about 1.5 seconds. Nothing was really being done, but we were able to illustrate to the user something is happening to protect your messages. Here is what it looks like for a receiver who does not have the POEM system installed. We have a very prominent call to action. Click here to get the system and install it, and you can see at the top we have that unencrypted greeting. Once they've installed the system, again we have the white on blue, so the receiver can be confident that here's sensitive information that's safe for me to use. So once we'd designed and implemented these modifications, it was time to validate them with a user study. So we recruited just over 50 participants and told them to help us improve email. We didn't want to prime them with any concern for security. So we just brought them in and didn't tell them what we were going to do. We designed 2 scenarios with a number of tasks to complete. We designed these tasks to really flesh out and evaluate any secure email system, not just ours. Things like replying, forwarding, carbon copying, attaching files, etc. So the first scenario was that a user had just been hired by a fictitious company, National Citadel, and they need to supply their social security number over email to complete the hiring process. National Citadel was the name we picked simply because it was one of our only ideas where we could secure the domain name. Now, the second scenario was the spouse needs to receive a login for their credit card website. In both these scenarios, the user would be interacting with one of us on the other end of the secure email channel. We'd be acting the part. And in both of these scenarios, the user would be using their own, not using their own sensitive information. We'd be providing them with false details to protect user privacy. And we were really after any qualitative and quantitative data that would allow us to evaluate the usability of this new system. So, to the usability, we evaluated it with the system usability scale, which is a series of 10 Likert scale questions. The user will interact with the system, answer the questions. We'll sum the results. It'll go from 0 to 100, and a higher score is better. And it really just gives a rough estimate for how usable a system is. So as you can see, we had over 5 points of improvement over 2.0, which was statistically significant. And to give context for what a particular sus score means, we can go to the work of Bangor et al. They collated thousands of system scores and assigned adjectives to different ranges of scores. So a score of 80, we can describe it as rated as A, it's excellent, and rated as acceptable. So this is really good to see. Now to give context for what a score of 80 means in the field of secure email, these are all the other scores we've received for any other systems we've evaluated. As you can see on the far left, we have Mailvelope. The earlier PGP-based system we evaluated off the charts. It's on the 4th percentile, really bad usability. And marginally low and high, we have a few systems there. Virtue and POM 1.0 edging into acceptable. And leading the pack was POM 2.0. So we're very happy to see that. For mistake avoidance, we definitely wanted to lower this. We found in 1.0 that 10% of users were using it incorrectly to send their sensitive information. And we were able to get that down to 2% for this latest version. So in over 300 tasks, only 6 of them were performed incorrectly. For the tutorials, we wanted to track how often users actually interacted with these things, because in 1.0, hardly anyone viewed the videos. So we found that almost every user completed the introduction and the read tutorials, and then over half did the compose tutorials. For user comprehension, we wanted to evaluate how well users understood what was being done to protect their messages. And so we measured the confidentiality, authenticity, integrity, with different questions such as who is able to read your messages. And so we definitely measured an improvement, but we can't tell roughly exactly how large the improvement was, because the questions we used were more strict. So the real improvement was probably much larger, or maybe not much, but it was larger than what we actually measured. For users' acceptance, we wanted to find out how readily the system might succeed if it was released in the wild today. And so we found that 82% of users would want to start using POM, 73% thought they could use it with their friends and family, and almost every user wanted to use it, thought they could use it with their friends and family. In fact, we'd have quite a few users leave the study and ask us, hey, can I go download this today? And we're like, well, yes, technically, but it's a research prototype and probably won't work for very long. More recently in this field, I want to describe a few things we've done. We've taken the user interface of POM and applied it to the message guard system, which enables us to do rapid prototyping of secure email. So if we have a question we want to answer, does this certain feature affect the usability of secure email or not, we can design an A/B study where we take the message guard platform, which provides integrated secure email, make a tiny change, and then run the study and see how it goes. This allows researchers to answer their questions and greatly expand the body of knowledge of usable secure email without having to go through the problem of actually implementing secure email from scratch every time. And that's available online at Bitbucket. As for user studies, we revised the methodology that we used in our studies. In this particular study, we brought in a single participant and had them interact with one of us who was acting as a knowledgeable user of the system already. We instead, into the two-person approach, we developed a methodology where we bring in pairs of participants, neither of which knew how to use the system. We'd stick them in different rooms and have them talk to each other and try and use the system. And this gives us really good information on the adoptability of secure email, especially in a grassroots fashion. And so that was published at CHI earlier this year. So in conclusion, usability in secure email has been a problem for a very long time, and we've aimed to address this with the POEM system to improve usability for novices. And the end result has been the POEM 2.0 system, which has achieved the highest usability score of any secure system we've ever tested. Thank you for your time, and I'll answer for questions.
Questions?
Hi, Darren Lay, Tactual Labs. I'm really glad to see this. I think usability is a very important issue with secure communications. I've seen some awful things in the past. My question is, how secure is this actually? How is this actually improving security, and how is this just convincing users to go through a set of steps that they think will make them more secure? If I were going to attack this system, I would make it look just like this, and the user would go and click and perform these several steps, and it would lead to something that would cause a man-in-the-middle attack.
So the security model that we used when evaluating the security of this system uses a term we called a honest but curious attacker, such as a webmail provider, who they're probably not going to interfere with the system and mock our interface to attack a user, but they will read anything they can. And so these systems here protect against that by using iframes to separate the content out so a webmail provider can't actually read the message's content. Now, you're right that it's open to an impersonation attack. As we said earlier, we're really aiming to improve usability, to really nail that, and then hopefully we can iterate, ratchet up security, and go from there.
Thank you.
Any other questions for Jeff? Yes, I'll ask a question. So you mentioned you guys had a lot of success with the context-sensitive tutorials, but I was wondering, in one of the conditions that you showed for composition, it was only 54%, right?
Yes.
But the other ones were over 90. Can you comment on the difference?
Let's go there. There we go. So I believe the difference is that the read tutorial and the introduction were much shorter than Compose. Compose had quite a few steps. You got to activate encryption, to-field subject, etc. And theorizing that by the time you get to Compose or to the subject, the user feels like, oh, I already know how to do secure email or do email in general. So I'll do that. So that's my theory.
Okay.
But, yeah.
Great. All right, let's give Jeff a big hand.